If you've got a great piece of music, Ioannis said this. If you've got a great piece of music, you can't predict the next note, but when it's over, it feels inevitable. So if you have a really compelling story, when it's over, people go, whoa, yeah, that's the way it is. So science gets us all to address the world in the same way. It doesn't tell us what's true. I mean, that doesn't make sense to me. It's not doing that. But what it does is to take different people with different perspectives, link the perspectives as best we can, and get them to converge on commensurate experience. See, predictions aren't any good because they're about the world. The great thing about commensurate experience is you've got your own experience. You know what you're talking about. So I have a funny notion about how science works. Robert Rosen, smartest guy I ever met, he once said, the most abstract thing you can possibly do is to make a measurement. Because in order to make a measurement, you have to choose to exclude all of the rest of the universe to get it. So science doesn't begin till you made an observation. I thought, well, that's true. But then we went back to our systems meetings and Rosen said, oh, Descartes was wrong. Science doesn't begin till you make two observations, because then you can get the differential. And it's the interpretation of the differential. The beautiful thing about a differential is you don't have to look at it. You got to that, take the one from the other, you got it. And the beautiful thing about models is they tell you things about the world and you don't have to look. So it gets you a little bit past the observation problem and makes the use of observations in science more powerful. I mean, people say, Alan, you're so goddamn abstract. You know, don't you rely on things like data? Push comes to shove. I understand about data. My scientific colleagues shock me. I mean, they get their exams and they're scientists. And they actually calculate the grade off the raw number of points the kids get right. I mean, no. I mean, it's a measurement. You have to scale it. You don't look at the voltage going through the pH meter. You look at the rescaling, right? So, I mean, I take observation and data and modeling very seriously. I just come down with some very counterintuitive things, which are very counter to naive realists, which is, if I look close enough, I will find reality. Well, there's lots of reasons to suppose that's not the case. It's not about reality. It's about getting good stories. And the best scientists know that. I mean, for example, the genetic code has a lot of stop codes in it, right? What do you think stop codes are about? The narrative is, once upon a time there was a question mark, and that was associated with the question, and then we needed a period, so we knew when to stop. Stop codes, they stop after 500 anyway, right? So stopping's not the hard thing. And then there's this other peculiar thing too, which is, of all the codes, so if you're reading the code and you start to read out a frame, you're reading nonsense, right? So at that point, you're not reading coded stuff. What you're reading is garbage. Some guys in 2007 did some research on 1,152 codes, all reasonable versions of the code. And of that, the actual genetic code came in second in its capacity to pull a stop code out of its ear at random. So what's going on here then is that stop codes are not about stopping regular reading. Stop codes are about stopping any other reading than the approved one. Right? And I have a model that talks about the old genetic code being able to read both strands, both directions, and that leads you to 20 words, which is why there's 20 words on the code. The paper's out. I've been cited 16 times for the wrong reason. So how come this code is actually, the two codes are orthogonal, and so what causes that massive rotation? What's the selective advantage? There wasn't much of a selective advantage. I mean, a little bit. You know, the third base redundancy sort of it helps you with mutations, but it ain't worth rotating a whole damn code for that. So what is it? It's that the prevailing genetic code has stop codes for weapons. Stop codes are not punctuation. Stop codes are weapons. They're six-shooters. And they jammed the old code. Okay, so now what I've done is change the narrative, right? And that's what really pisses off the people who actually do the research. Go, well, where's your new data? I don't need new data. I was thinking you were. they won't let you comment unless you have new data. It's part of their culture. So what's happened is all I've done is change the narrative. And I've changed it from punctuation to weapons. Okay, this opens up a whole new bunch of research. If stop codes are weapons, maybe cancer is using stop codes as weapons. If stop codes are weapons, maybe we can use stop codes against cancer as weapons. And all I've done is to change the narrative. Whereupon, the guys who actually do the lab-based stuff are heading in possibly enormously helpful directions. So the power of it is narrative. And I was talking to Bernie Weisblum. I think he may or not have retired or not, but he's still in his lab. I said, so what do we do, Bernie, when it just gets all too much? He said, we tell stories. The best of the best. No, we tell stories. The B team believes models are real. And the answer is no. Models are great, but they ain't real. Yeah.
Okay. I have a question. If you said that science isn't about getting at the truth, and it is about telling good stories and so on and so forth.
Telling useful stories.
Yeah, telling useful stories. Okay. Then what's the key difference between science and pseudoscience? Because normally I think of science as being about truth and pseudoscience.
Well, yeah, but it depends. For example, one of the good things about science is it has two versions of quality.
Okay.
One of them is structural quality, and it achieves that with lab notebooks and being able to respond to an editor who says, do it again, and you do it again, and damn if it doesn't work out the same way. So, these are my grad students over here. I'm training them to have structural quality. I'm the master. The master doesn't do what the apprentices do. I know all about that stuff. My job is to pull the rug out from underneath the structural quality. It's dynamical quality. So the power in science is the way that there is challenge at every level. I mean, you set up a null hypothesis and knock it down. You change this line of work's not going, I'm going to go there. Or in the end, you say, Newton, wrong, Einstein, right. But notice the old paradigms don't go away. We still build bridges with Newtonian mechanics, not quantum mechanics.
Yeah.
Right? So what's happening there in science is the development of powerful and appropriate narratives. Restate your question.
Basically, I was just asking if you said that science is about telling useful stories and not so much about truth, then what's the most important difference between science and pseudoscience? So
the great thing about science is it has lots of structural quality and lots of dynamical quality. Right? They get the details right. That's what the lab-based people do, and they get the big ideas right. National Enquirer is very bad on that. National Enquirer has they get a little piece of data that they can twist to indicate that aliens really did da-da-da-da-da.
Yeah.
Right? Then when they find counter evidence to that, they ignore it. Right? So it does exactly the wrong thing. Right? So National Enquirer is low quality, whereas science is high quality. But if you want to sell a lot of newspapers to an ignorant American public, National Enquirer is very high quality. It depends upon what you're talking about. It depends upon the context. That's the deal. So pseudoscience, sometimes it gets people interested in science. Sometimes it's so goddamn crazy we go, whoa, maybe stop codes are six shooters. Right? It's bad science, but
okay.
All right, we're going to go ahead and wrap it up there. Everybody, thanks.